Hi everyone, this is Irfan Sheikh. So today we are going to discuss about the distributed systems project. The course number is CS 553 under the Professor Mark Grushenik. So we simulate a network graph where each node is an Akka actor. So today I will show only in this video I implemented two algorithms here. On this demonstration I will show you the ring election algorithm. Okay, so that's it. So before starting our project we will see our exact layout, what are the prerequisites needed. So actually what happens is we need some actors to create it, right? So for the actors we are using the net game sim. We are using the net game sim here. So this is the all the folders which is given by the professor. He generated this platform to build a graph. So I have chosen the 10101 states. Why? Because if I take the high states, so I think it might uh, disturbs your RAM process. So I thought I would like to take the 100 states. So after taking the 100 states, I have generated all the net graph under the .ngs. You could even see the nodes which I have created. So I have created the 101 nodes. So this is the phase one of the project. So we needed at least the JDK, SBT, and Scala, all these. After that, once we create this netgraph.configuration file, we directly going towards the first configuration file. Okay. So this is the configuration file which I have created. So we are using the ping, gossip, work messages, and this is as a traffic, and also the PDF which uh, edge probability is lesser. So it's 0.5, 0.3, 0.2. Okay. After that, we will see the report. We will go towards here. So it's better to see here. So this is the architecture of our overview. So you could also go through with in this format itself. So first go with the config file, or before that create the graph with whatever nodes which you needed. After that go with the config file. After see this report first before starting the project. Okay. So after the net graph JSON net game sim graph is generated, right? So we have to load that generated graph. After that we have to enrich with the edge labels, node, and the probability distributed functions. So after enriching all the stuff, right, we have to do sim runner. We have to run in the actor system where we are implementing these two algorithms which I got to do. So first one in the probability and string election, in the Peterson the rollback, Hence rollback. Okay, so these are the basics. So if you want to know what is exactly about this algorithm, you can go through this enter content which I have pasted. So after getting this netgraph dot, so we will just moving towards the next whatever the generated file which I got is read. So you could see the same graph here. It's after that now we are moving into the project. So what are the SBT version I have used, and what are the plugins? So the main thing here is, though this is a reproduce.sh, so it's not required. So the main thing here is the algorithms which we are implementing. So I implemented the election algorithm, and the second one is a recovery algorithm. So with the help of this API, so main file. So I also written the few test cases. At the end of this video, we will gonna check the we will gonna see the test cases, whether this test case, we have if my entire system is running fine, then I have to run all the test cases which are created. Okay, so this is the logging. And so let's go and we will run the command. I will go to my terminal. I will just run I have just created the outputs run ring election algorithm. So I have given here for 30 seconds. So what you have to do, so to run the same thing, right? So you just go to my Redmi file, just open it, just go through this entire video folder. You just have to copy this path. Okay. If you want to run this ring leader election only, just copy this path. If you want to run the rollback only, just copy this entire command. If you want to run the both algorithms, which is ring election and the rollback, you have to use this both algorithm. So you could see here run both. You will create the folder called run both, run rollback, run ring election. I just now created the run ring election algorithm. So let me see our outputs folder. See here, this is our run ring election algorithm. If you see the output file, right, you will also generate the same file, the similar kind of file. You could see the who is the leader. So let me search here leader. So the leader elected with the value 0 point something. Who is the leader today? The leader is the 56. The node 56 is our leader. Understand? So this is the base algorithm. So that's it. So for my you just need to just SBT compile, and you have to run this SBT test. Okay. So after, and we will check the few test cases too, so that we could understand SBT test. We are running the SBT test. Okay, it's perfect, right? So run completed in 1 second. So all succeeded. All that succeeded 8 test cases. All succeeded two. So all the test cases was passed. All the flow is correct. All the graph after graph enriches test, we graph enriched, then we tested it, and we have seen the PDF sample test, and we have, so all the test cases were passed perfectly. So this is the main thing which we have to analyze. So we will just see the one smoke test directly. So if I use this command, the what the command does is just compile the my SBT file, then it just SBT test, then it just go for the, it will create one output folder called smoke. Then it runs for the 10 seconds only, because I don't want to utilize my much time, so I just want to run it for only for 10 seconds. Let's go and check it back. Okay, it's compiling, the compilation done, now it's running. Okay, the alt is, so everything was done. Okay, so it's running the Peterson rollback. See here, it's running the Peterson rollback algorithm. Okay, so it's done. Actually, the Peterson rubric is also done. So we'll just go through it. Then, so this is the smoke folder. So if you go through here, so he runs this one different algorithm, right? So so everything was perfect. So this is the main important thing. So sometimes what happens, the cinnamon, the lightband library is giving some problems. So it's better to use the entire Maven Central if you want to use it. So it's just getting the metrics collector. So it's, I prefer to use this metrics collector because everything is going towards a Maven. So it depends on you. I mean, if you are comfortable with the lightband, Akka lightband, so you could use that too. So, and also, so this is the flow of the entire thing. So if you have any doubts, just go with those readme files, just see the first see the flow of the everything, you could understand easily. First go with the report.md, then use this readme file, then just run generate the net graph with the help of the net graph sim. Then after that, just run these entire commands. You will get the exact answer what I am getting here. So this is the entire project. So thank you, Professor Mark Grishanik. It's a really wonderful project. So where I'm implementing a good algorithm. So I understood the different. So what is a actors? How do we can implement in a real life based? So thank you very much for giving me this a wonderful project. Have a nice day. Bye.